First, I would like to apologize for my voice. I caught a bit of a cold and I had a pretty rough night out on Saturday. I drank all the tea in the world yesterday and it still didn't help much. So my name is Milan Györki. I work as a product owner for Ericsson. And first I would like to start with a short story about me and OpenStack, how we first met. It started 2 years ago. I moved to a new project that was about virtualizing our existing product. I thought about it as a straightforward task. I mean, we already did it once, we can do it again. Only this time we will use x86 COTS hardware and Linux operating system. So when I started to get involved, I heard the word OpenStack more and more. At first, my solution to this was to simply just ignore it and don't worry about it. But as time passed on, I had to realize that probably in order to be able to do my job, I would need to learn what this OpenStack is. Because, well, here comes the analogy. Okay, so technology is like ice cream. There is always a flavor of the month, always the one that everyone is talking about, the hot topic. But the thing is with flavor of the month, usually you do not remember what was the flavor of the month, I don't know, last year, August. They go out of fashion pretty fast. But on the other hand, they are the seasoned players, the chocolates and vanillas, that you can always build a solid foundation on top of. And what I had to realize is that OpenStack is such a technology that you can build reliable applications on top of. So a couple of words about who we are, what we do. I say here, or I wrote here, out of the box, and I mean that literally and figuratively. Literally because we were actually a hardware box with its specific hardware, its own specific operating system, own platform, and of course a specialized application fit to do one thing only, or actually multiple things. And figuratively, because in order for us to be able to create a cloud-agnostic product, we also had to do a paradigm shift. We have to realize that we are just a small part of the whole system, and we are not the center of the universe. You need to build a cloud-aware product and not build the cloud around your product. I guess many of you heard about Pareto's principle. It states that 80% of effect comes from 20% of causes. And this can be applied actually in the software development scene. It states that the technology advantage, the 20%, that you need to build yourself, and the rest, the 80%, that can be done in open source. You do not need to build a full stack, a full solution, only your specific competitive advantage, the thing that your organization is good at. And most organizations, or at least what I know, are not actually that good that they can build a whole platform by themselves. At least not today, when there are such complex systems. But of course, the 80%, in order for being able to host carrier-grade solutions, it needs some kind of coordination. This is why in 2012, the network function virtualization, or NFV concept, was born. It is for creating IT-level virtualization technologies to be able to host carrier-grade attributes like high availability, scaling, performance, and easy network management. And for the whole effort, the OPNFV was founded by the Linux Foundation that hosts multiple projects that strives to make the NFV concept a reality. Actually, people from my team are also involved in OPNFV. They are currently contributing to the Yardstick project. It is a project in OPNFV, and it is to check or test the compliance of infrastructure, like OpenStack, for example, to be able to host NFVs or VNFs, virtualized network functions. Through our domain-specific knowledge, we are actually creating test cases that are verifying the infrastructure from a high packet throughput view and testing delay and jitter. And now I'm starting to get at the point of what was that enabled our migration to the cloud. What were those specific features, at least a couple of examples in OpenStack that gave us the opportunity to create a cloud-agnostic product. So what were why are we special? What were our requirements when we moved to the cloud? So our application has a real-time behavior. It requires a high network throughput. We have some tasks that are quite processing power heavy, and we have a sensitivity to delay and jitter. Usually, virtualization doesn't improve on these characteristics. So a couple of features, for example, no one likes noisy neighbors. I mean, there is a difference if you live in a flat compared to moving to your own house. When you are in your own house, you own your resources. You don't share them anymore, and you got rid of that noisy neighbor on floor 6 who was practicing drums during weekends. So this is what core pinning or pCPU to vCPU core pinning gives to your virtual machine. It creates a one-on-one relationship between physical CPUs and virtual CPUs, and this means that you don't have to share the physical. Your VM doesn't share the physical CPU, and you won't have to care about processor steal time. Another example in networking or, let's say, traveling. So there is a big difference if you are traveling by air. You can have a direct flight or you can have a transfer. Of course, everyone prefers the direct flight because it's much faster. And this is what single root I/O virtualization gives to your application in the packet domain. Usually, a neutron port is connected either to the OVS port, the Open vSwitch port, or a Linux bridge. But single root I/O virtualization, of course, it's not part of OpenStack, but OpenStack gives support for it. And you can share physical NICs. You can virtualize physical PCI Express devices in a way that they can appear as multiple virtual functions of themselves, giving your VM a direct access to the hardware. It's actually not quite direct access. It has access to the virtual function, not the physical device, of course. And that way, multiple virtual machines can share the same physical interface without the packet copying that usually goes around in the Linux kernel. Another similar solution is that you, instead of normal obvious data paths, you can use the accelerated, DPDK accelerated data paths. This solution has a similar effect as single root I/O virtualization, but of course it's a little bit different. The packet throughput numbers will be roughly the same. But of course, we still have a long way to go. There are still some features, some characteristics that we would like for OpenStack to have in the future. What are these? A couple of examples. I have to first talk about how we are testing our application. For us, actually, virtualization or cloudification has opened up new doors in testing. You don't need to deploy physical servers or physical devices anymore. You can just deploy VMs, so scaling and deploying of our test system has become significantly cheaper. This means that we are constantly spawning, decommissioning virtual machines, and of course creating neutron networks at a high rate. This is, of course, another important difference between our application and usual cloud application is that we have a higher than usual amount of neutron networks. So during these tests where high amount of automation can be utilized, I mean in spawning the virtual machines and bringing up and tearing down these test systems, we sometimes see interfaces being reordered. In other cases, we saw missing interfaces. And the DVR feature, for example, the distributed networking, as far as we know, there is a limitation currently that you cannot spawn more than 3 VMs at under 1 minute, which use case at this point maybe doesn't seem so realistic, but in the future it's quite easy to actually imagine that will be actually a use case. We also see sometimes hanging resources, and due to this, actually we had to invest into monitoring features and cleanup scripts that are constantly monitoring and maintaining the health of our cloud deployment. And the question arises here that is this actually really the responsibility of the application, or maybe the cloud infrastructure should have some solutions for these kind of problems. I did it again. Okay, so the main advantage of having, I mean everyone knows this, the main advantage of having a cloud application is a fast, easy upgrade, easy deployment, and the release cycle, and the fast release cycle that mostly enables all of this. On the other hand, we have the infrastructure, OpenStack here, which has a half-year release cycle, quite complicated deployment, and currently a non-existent upgrade. But there is hope. I mean, we can cry a lot about what we want OpenStack to have, and we can give talks like this that I want this and this from OpenStack. But now that we move to open source, we actually have the power to influence and to fix our problems for ourselves. And we have a pretty nice collaboration example ongoing between the open source community and Ericsson, the Cinder multi-attest story, which enables a single block device to be attached to multiple virtual machines. And let me give the word to my dear colleague, Ildikó, who will introduce the Cinder multi-attach feature and what has been ongoing in that scene recently.
Thank you. So before sharing the story within the story with you of how to implement and add the new feature to OpenStack, let me give you a little bit of a context at what this feature means in reality. So here is, I think, quite simple diagram. So let's start with the right-hand side. The Cinder node and one of the Nova Compute nodes. So on the top of the diagram, you can see this, well, dark green-ish line that goes from Nova to Cinder, and then the same color line goes from Cinder to the Linux Volume Manager. That is the volume control flow. So this is how the whole volume creation and attachment is going on. And the volume data is depicted by the orange flow at the bottom of the diagram. So here you can see that when you're attaching a volume to a Nova Virtual Machine instance, then the whole flow goes through the hypervisor. And here on the diagram you can see that it shows the iSCSI protocol, but Cinder itself supports other protocols like Fiber Channel or NFS as well. And same goes for the Linux Volume Manager. There are other backends and drivers that are also supported by Cinder. So in case of today, where we only have possibility to attach a single volume to a single instance, and that's all that we can do. You can see that the flow goes through the iSCSI initiator, and then on the Cinder node, it gets into the target, and through the volume manager, you will actually finally get access to your volume. So what we would like to do here is add the capability of attaching that simple and single volume on the right-hand side to multiple VM instances, regardless of whether they are on the same host or on different Nova Compute hosts. So it's really not that difficult. In case of the LVM driver, you can see that we have a second Nova Compute host on the left-hand side with 2 VM instances, which are or to which the volume is also attached to. So the light green line shows that the connection goes through one connection, so they are sharing the same iSCSI target in this case, which, remember, because this will be important later. But for now, I hope you agree with me that this is really not something that looks difficult. So you might wonder why I will spend, well, roughly 7 more minutes of talking about this thing. So let me come back to the story because, well, yeah, we have quite a bit of a history with this feature because it exists today only on the Cinder side. So we already have some multi-attach support in OpenStack, but the trick is that, by the way, you're just really not able to use it at all because today Cinder and Nova is so tightly coupled that when you don't have this feature enabled in Nova, then you just really have no access to it. I actually had a nice pocket watch in this slide, but then the brand people told me that it's really, really not compatible, although it was really stylish, I swear. And I thought that I will put it on the slide just to really show you that for how long it's been going on. Because you can see on the slide that in Cinder, this feature was actually added in Havana, which was more than 2 years ago. So if you would ask me that why the first few attempts to add it to Nova as well failed, I cannot really answer you because I was still in kindergarten. So I got from the branding people, just to go back to the icon, the nice rewind one. I realized that, by the way, they didn't really make a mistake by changing the icon because this is actually how it works in OpenStack when you're trying to add a feature and you cannot finalize it in one release cycle, that during the next release cycle you actually have to go back and start the whole thing almost from scratch. So for example, you need to have the blueprint specification accepted again. So we are kind of restarting in every half year. Really, really painful, but we are progressing. So I'm kind of following the activities since the Kilo release cycle, and yeah, the implementation was slow, so it wasn't finalized. And then during Liberty, we found some bugs with detaching, but who cares, right? I mean, yeah, we notified the Cinder folks that something is really, really weird, but we couldn't really report even a normal bug in Launchpad in OpenStack, which we are using for tracking issues, because the end-to-end feature is not existing at all today. So is it a showstopper? Oh, well, no, just let's move forward with the implementation parts. So this is where we come back to the item that I told you to remember, which is the very same iSCSI target for a particular host. So no matter how many VM instances you have on that host, in case of the LVM driver, you will get only one iSCSI target, which does not really seem like an issue, but as how Cinder is implemented today, this means that when on that second Nova Compute host, if you remember, you detach, issue the first detach call, that actually will remove the whole iSCSI connection and the target on the Cinder side. So this means that theoretically you still have connection and the second attachment, but in reality you don't have that. So you're still existing and running VM instance that thinks that it has access to that volume, it does not have it anymore. But, well, still does not sound like a big issue because, yeah, let's just fix the LVM driver and then we are done. But it kind of, we had to realize as looking deeper and deeper into this whole mess that it's not that easy because LVM driver behaves like just how I described. But there are other drivers which may be exporting one iSCSI target per attachment, so kind of problem solved by itself. So we cannot really add a generic solution to this problem, which is, by the way, really not a difficult problem in itself. So this is why we are spending even more time than how much we spent already, because now that we know that we need to look deeper and in order to fix the issue, we need more information on Cinder's side, and then we need more information in Nova as well to figure out when to remove this whole connection thing. So many discussions and weekly sync meetings later, we kind of figured out that, okay, let's take a step back. And currently today, we are at the stage of refactoring, I think, at least the half of the Cinder API. Because the plan is to simplify the interaction between Nova and Cinder and move all the responsibilities to the Cinder side, which is supposed to be there already. But because Nova was really the starting point for OpenStack itself and the core services, there was some parts of the code that just remained there, and then people picked it up and they just started to use. So we have some redundant functionalities within Cinder and Nova. So we ended up with a larger refactoring activity, but I personally believe that we are now really on the right direction. And theoretically, still within the Newton cycle, if we are really efficient and lucky, we can have the feature finally implemented, and we can also have all the advantages of having a simplified connection between these two core modules, which would be a really good news for those who would like to come and contribute to either or both. So we are trying to make maybe your lives easier as well. And really good news that last week was the blueprint specification freeze and deadline in Nova, and we have the multi-test spec accepted again maybe for the 5th or 6th time. So it is a long process, but what's going on, it really shows that OpenStack is maturing. We are identifying problems, we are identifying root cause, and we are getting there to fix it really as a cross-project interaction and as a real collaboration by the end of the day. So hopefully, within Newton, we will finally have this feature that we would like to have for so long now. And one thing to remember you, that OpenStack is the infrastructure as a service platform. So it will not solve the issue for you that what's going on inside your VM. So remember that when we will have this feature supported by OpenStack, it means that the borderline is your VM instance and the hypervisor. So what's going on in your guest OS, that's totally your responsibility and your application's responsibility, which means that you need to figure out that what will happen with all the caching and everything that can just still screw things up. We will figure it out for you in the hypervisor and in Nova and in Cinder and on the host. But on top of that, it's your journey from that moment. And here is when I would like to give the word back to Milan to summarize what you heard today.
Okay, thank you. This was very educational. So just for final words, final thoughts, always concentrate on your core functionality. Never waste any resources to build platforms and full stack solutions. For this to happen in the telco sector, OPNFV and the network function virtualization concept had to happen. But these new use cases are also bringing out new instabilities in the platform. And as we can see, profit-driven businesses can also feed back to the community new features that can be beneficial for all stakeholders, not just for ourselves. And that was it. Thank you. We have 2 minutes 30 seconds for questions if someone would like to ask anything.
I hope it's just only because we were so straightforward and not because we were so boring.
I would say this is a no questions. Then in that case, thank you for your attention.